Welcome, everyone, to Techaily.ai. This is the Deep Dive. And today, well, we're plunging right into probably one of the hottest topics out there, generative AI. We're putting a sharp focus on the absolute latest from OpenAI GPT-5. Our mission here really is to unpack not just what it can do, but how it's changing things, industries, the economy, even just our daily lives. We're going to zero in on the ethics around GPT-5, the economic shifts, the practical side of it all, based on some really fascinating stuff you've shared. Oh, and before we really get started, a quick word about our sponsor. This deep dive is sponsored by Stonefly. They're your trusted solution provider and advisor for all things enterprise storage, backup, disaster recovery, hyperconverged setups, VMware, Hyper-V, Proxmox clusters, you name it. Also AI servers, the SA365 turnkey security appliance, plus public and private cloud solutions. Definitely check them out at stonefly.com for more info. They're really doing cutting-edge work in IT infrastructure. Okay, so GPT-5, the buzz has been building, hasn't it? And now, well, it's actually starting to roll out. OpenAI's latest model, GPT-5. People are saying it has these unprecedented capabilities. It's not just about churning out text anymore. We're talking a serious jump in automation, in complex problem solving. They designed this thing for genuinely enhanced reasoning, more creativity, and just a much better grasp of context. Now, if you're in the dev community, you might already know it's in public preview for GitHub Copilot users. That started August 7th, 2025. And kind of behind the scenes, it's also the engine for Microsoft 365 Copilot and Azure AI Copilot. So it's slipping right into our everyday work tools. But with all this power, it's not just about the tech specs, is it? There's this whole human angle, the societal impact to think about.
Absolutely. And what's really striking is how fast the conversation shifted. It went from, wow, look what it can do, to, okay, wait, what are the ethical implications? Almost overnight. And these aren't small questions. It's sparking really intense debates all over the world. A major one, and it comes up again and again, is algorithmic bias. Just picture it. These huge AI models, they learn from enormous data sets, right? But if those data sets reflect, say, historical biases in hiring or loan approvals or whatever, well, the AI learns those biases too. It doesn't know any better. So it can end up making discriminatory recommendations or decisions, maybe hitting marginalized communities harder. It's not like it's trying to be biased, but the pattern gets baked in. And then there's the whole issue of misinformation, AI hallucinations and the absolute need for strong data privacy. It's a real ethical minefield.
Yeah. That bias point is pretty sobering. But, okay, setting the ethics aside for just a second, what about the immediate, boots-on-the-ground impact, people's jobs? Are the fears about job displacement just hype, or is there something real there?
Oh, it's definitely a real discussion for the labor markets. We are talking about potential job displacement, especially in industries heavy on routine cognitive work. Think about customer service roles, data entry, content moderation, maybe even some parts of journalism or graphic design. Imagine a small marketing agency. Maybe one designer used to spend ages making variations of banner ads. Now AI pops out dozens in minutes, so that designer's role, it shifts. Maybe it becomes more about directing the AI, refining the output, less about the manual grunt work. So it's often less about jobs vanishing completely and more about jobs changing, needing new skills.
Right, transformation, not just elimination. And connecting that to the bigger picture, it really highlights why regulation is suddenly such a hot topic. You see governments kind of scrambling, trying to get frameworks in place, like the EU's AI Act that tries to sort AI by risk level. It's one approach. And in the U.S., different agencies are trying to figure out their own guidelines.
Exactly. Because deploying this AI ethically isn't just about, doing the right thing for society. It's also about market stability, investor confidence. A big misstep here could ripple out, affect stock prices, consumer trust, everything.
Okay, so we've touched on the immediate stuff, the challenges, the changes, but this links to a bigger question, maybe more philosophical. Is generative AI just another tool, a fancy calculator? Or is it something more fundamental, something that changes the game entirely? To get at that, let's unpack this idea of a general purpose technology, a GPT, and maybe an analogy helps here. Think about the light bulb. Revolutionary, right? Totally changed things. It gave this temporary productivity boost. People could work later, safer. But once everyone had bulbs, that initial surge kind of plateaued. Now compare that to the electric dynamo. That didn't just provide light. It fundamentally changed how factories were built, how power was distributed. It unleashed waves of what they call knock-on innovations. Whole new industries, products, processes, all spinning off from that core tech over decades. So the big question we're wrestling with is, generative AI, is it the light bulb, a temporary boost? Or is it the dynamo, sparking a long-term, deeper revolution?
That's a fantastic analogy because, for something to be a true general-purpose technology, a GPT, it generally needs to tick 3 boxes. First, widespread adoption. It has to spread across many different sectors, not just stay in one little corner. Second, it has to trigger lots of those knock-on innovations. Think new products, new services, new ways of doing business, new organizational structures even, that just weren't possible before. And third, the core technology itself has to keep getting better, continuously improving, opening up new possibilities, feeding that innovation cycle. So let's look at the evidence. What about that first point, widespread diffusion? The numbers are actually pretty interesting. McKinsey found, 72% of large firms are using AI now. And for generative AI specifically, usage in those large firms basically doubled in a year from about a third in 2023 to two-thirds in 2024. That's fast. Now, the Census Bureau's data, looking at all U.S. firms, shows about 9% overall using AI. But dig deeper, and for the bigger companies, say 250 plus employees, that number jumps way up. So it seems adoption is definitely concentrated in larger organizations, at least initially. But look at individuals. One survey said 40% of U.S. workers are already using generative AI. And get this, 86% of programmers, 69% of graphic designers using it already.
86% of programmers. That's huge. Why so high in those fields, do you think?
Well, I think for roles like programming or design, the tools are just so immediately useful, right? It's like getting a super smart assistant instantly.
Makes sense.
And you see this adoption fueling the second criterion, those knock-on innovations. Suddenly there's this whole ecosystem popping up. New interfaces like ChatGPT, custom GPTs. Google's Notebook LM is neat. You feed it documents and it helps you analyze and discuss them. Then you've got the Copilots, GitHub Copilot for coding, Microsoft 365 Copilot for office work. They slot AI right into how people already work.
But then it gets even fancier with things like agentic AI, AutoGen, Crew AI. These aren't just doing one task.
Yep.
They can handle complex multi-step processes. Like, imagine automating an entire flight picking, searching options, booking, handling changes.
Complex workflows.
Exactly. And we're seeing it transform product design, think DALL-E, for images and even factory floors with predictive maintenance or optimizing production lines.
Right. Which brings us perfectly to that third GPT criterion, ongoing core innovation. And the pace here has just been relentless, really, since the transformer architecture dropped in 2017.
That was the big breakthrough, wasn't it? The transformer.
Oh, yeah. Fundamentally changed how models handle language and context. And since then, progress has been driven by just massive increases in scale. GPT-1 had 117 million parameters. GPT-3 jumped to 175 billion. Plus, way more computing power, way bigger training data sets. But here's a kicker for productivity. The actual cost of training these models for a given size, you measure it in dollars per TFLOP, basically cost per unit of computing power. That cost was roughly halving every 8 months through 2024, mostly thanks to smarter algorithms, more efficient ways of training.
Having every 8 months. That's incredible efficiency gain.
It is, and new tricks are constantly emerging. Things like mixture of experts or MOE. Think of it like having a team of specialized AIs that get called upon depending on the problem.
Yeah.
Super efficient. And quantization, basically finding clever ways to shrink the models down so they run faster and cheaper without losing too much accuracy. These aren't just small tweaks, they're making powerful AI much more feasible.
And speaking of feasible, DeepSeek R1, that just came out, January 2025? Apparently, they trained a model with 671 billion parameters for just $6 million. When I first saw that number, I thought it had to be a typo, 6 million. For that scale.
It's pretty stunning, and it uses a mix of those advanced techniques, MOE, something called chain of thought reasoning, reinforcement learning. It strongly suggests we're going to keep seeing these big performance gains without costs exploding, which is, really promising for making this tech widely available.
Okay, so if generative AI is a potential GPT, reshaping whole industries, could it also be reshaping the process of invention itself? That brings us to another really powerful idea. Generative AI as an invention of a method of invention.
Yeah.
An IMI. So an IMI. It's a technology that doesn't just produce something new, it makes the whole R&D process more efficient. So think about the compound microscope. It didn't just let us see tiny things. It fundamentally changed how scientists did research, opened up microbiology, pathology.
Exactly.
And the argument is generative AI might be playing a similar role today, accelerating discovery itself.
Yeah, it really seems to function as an IMI in at least 4 different ways. First, it's an observational tool. It can take imperfect images or data sets with missing information and clean them up or fill in the gaps, often better than older statistical methods, so researchers get a clearer view of their subject.
Enhancing the raw data.
Exactly. Second, it's an analytical tool, sort of a microscope for social stuff. It can do sophisticated sentiment analysis on vast amounts of text or find patterns in communication, making social science questions that were previously too complex actually researchable. Third, it's an organizational tool. It helps create digital twins, virtual models for things like drug discovery or material science or industrial processes. This could potentially cut down on the need for huge labs or physical testing, like using JANs, those AI models that generate realistic data for toxicology studies, instead of relying solely on animal testing. Streamlining research.
Interesting. Using AI to simulate real-world experiments.
Precisely. And fourth, it's a communication tool. It can help researchers with all the writing involved: drafting papers, great proposals, even presentation slides. Think of it like the printing press or word processing tools that just accelerated the spread and development of ideas.
That communication part,
Right.
it leads to these research agents, doesn't it? Like Google's AI co-scientist or Sakana's the AI scientist. The idea there is pretty wild. Systems that try to automate the entire research workflow, generating hypotheses, designing experiments, running them, writing up the results.
Right.
And there was that incredible claim producing publishable research for as little as $15 per journal article. I mean, that
Yeah.
sounds almost too good to be true.
Well, and maybe it is, for now at least. While the potential is huge, it's really important to temper that excitement. Some early evaluations of these systems found critical shortcomings, things like the AI thinking an old idea is brand new, or making coding errors that mess up the virtual experiments, generating flawed results, even citing papers that don't exist, or worse, hallucinating numerical results, just making up data points.
Oof. Hallucinating results in science. That's not good.
Not good at all. It raises this fundamental question: are these models capable of genuine discovery, uncovering new laws of nature? Or are they just getting really, really good at mimicking the patterns of scientific writing based on all the papers they've read? It's a critical distinction. But even with those caveats, there are concrete signs of generative AI impacting research right now. Look at patents. AI-related patents granted by the U.S. Patent Office, up 50% since 2019, right after generative AI really took off. That suggests a lot more AI-driven R&D.
Okay, that's a solid indicator.
Yeah, and remember that analysis of prompts given to Claude AI, it showed people in computer and mathematical occupations, and scientists were using it way more often than their share of the workforce, like 11 times and 7 times higher, respectively.
So the people actually doing the research are using these tools heavily.
Seems like it. And you see it in the business world, too. The number of public companies mentioning using AI in research context during their earnings calls, it's been around 60 companies per quarter consistently since 2023. So these are all signals that, yes, it's integrating into how innovation actually happens.
Okay, so pulling this all together,
Yeah.
where does this leave us looking ahead?
We have to admit, right, that despite all the buzz and the undeniable progress, the real economic impact of generative AI, it's still pretty fuzzy, still uncertain. I mean, remember when GPT-5 first hit public preview? The reactions were all over the place. Some people were like, it's incremental, not the huge leap I expected. Others saw definite progress.
Right, that mixed reaction tells you something.
Yeah, it shows the debate is still very much alive about how big a deal this will ultimately be. And there are real hurdles. One is just the sheer computational demand. These things need enormous clusters of GPUs, sucking down incredible amounts of power. But there's a counterpoint. Remember that stat about the cost of compute dropping? That price per TFLOP falling 24% per year for 17 years. That helps make the cost side more manageable over time.
True, efficiency gains are key.
And on the power consumption front, well, the energy efficiency of the big supercomputers used for this has actually doubled, roughly, since 2022. Plus, forecasts show U.S. electricity generation capacity is set to expand significantly. So maybe the energy crunch won't be quite as bad as some fear. Another big piece is data limitations. These models need oceans of data to learn, and there's this growing feeling that maybe we're hitting the limits of useful public text data available online.
Running out of internet to feed them.
Kind of. So solutions involve things like transfer learning training on public data, then fine-tuning on specialized proprietary data sets within a company, and then there's synthetic data using AI to generate new data to train other AIs.
AI making data for AI.
Yeah, but there's a catch. If that synthetic data isn't high quality, you risk model collapse, where the AI starts learning from flawed generated data and its performance actually degrades. It's a tricky balance.
So framing the future, it feels important to say this. Generative AI doesn't need to achieve artificial general intelligence AGI, that human-level adaptable intelligence, to be massively impactful.
Absolutely not.
It can absolutely be a GPT and an IMI long before we get anywhere near AGI, if we ever do. The productivity gains, the innovation acceleration that's happening now.
That's right. But maybe a couple of final cautionary notes. First, the real productivity impact of a true GPT. It takes time, decades often. Think about computers, solid-state computing revolutionized things, but the big economic effects played out over a long period. It's not an overnight switch.
Patience is needed.
Definitely. And second, investing heavily in the infrastructure for new tech always carries risk. History's full of examples. Think about the 19th century railroad booms and busts, or the dot-com bubble bursting after massive overinvestment in telecom infrastructure in the late 90s, early 2000s.
Building it before they come, sometimes they don't come as fast as you expect.
Exactly. There's a risk of overbuilding data centers, power generation based on hype or projections about AI demand that might not materialize quite as planned, leading to a potential boom-bust cycle there too.
Okay, as we wrap up this really fascinating deep dive, here's something for you, our listener, to think about. We've talked about the incredible potential of generative AI, but also some very real risks and challenges. So the provocative thought is this: what steps do you think governments, companies, and just us as a society need to be taking now? How do we make sure the benefits are shared widely, the risks are managed effectively? How do we guide this powerful technology towards a future that's not just smarter, but also genuinely fair, transparent, and accountable? Something to chew on.
Well, thank you so much for joining us on this deep dive into generative AI and the dawn of the GPT-5 era. We really hope this gave you some clear insights into this incredibly fast-moving field. And one last reminder about our sponsor, Stonefly. Definitely check out their incredible offer, a 100 TB immutable and air-gapped SSO NAS for just $8,995. That's a serious piece of kit for secure storage at a really compelling price point. Again, 100 terabytes immutable, air-gapped, single sign-on NAS for $8,995 from Stonefly. We look forward to having you back for our next deep dive.